Hello, my name is Marlee Miller, and I will be presenting my team's capstone project called Track which is a wheelchair wheel cleaning device. This project was sponsored by the Craig H. Nelson Foundation and the Shepherd Center. This is our team. From the left, we have Jasmine, Chrisp, myself, Marlee Miller, Courtney, Wolpov, and Brooke, Jarrett. Our project was focused on developing a user-friendly drive wheel cleaner for long-term manual wheelchair users, which is easy to use, quick, and reliable. The way our sponsor outlined the project is to come up with a wheelchair user equivalent of wiping their feet before they enter a home. Currently, there are no commercial products on the market that help clean wheelchair wheels. Typical wipes and handheld brushes are difficult to use for quadriplegic individuals with limited use of their hands and limited flexibility. So this project is aimed to accommodate all manual wheelchair users, regardless of their arm and hand mobility. For reference, I will be referring to the front small wheels as the caster wheels and the large main wheel as the drive wheel. There are many factors that need to be addressed to make an effective product. Wheelchair models differ widely in caster size, distance between the caster and the drive wheels, positions of the footplate, width of the chair, and the drive wheel tread type. Additionally, the typical wheelchair user has limited mobility of their arms and hands, so the product must require little grip strength and no fine motor skills. Each wheelchair model also has variable caster wheels that differ in position and diameter. Furthermore, the product must be portable and lightweight, so the device can be moved or packed into the trunk of a car. Finally, the device must be modular, so the device can be disassembled for easy cleaning and any worn parts can be replaced. The device is easy to use and intuitive. First, the user notices that their wheels are dirty and goes to roll backwards up the ramp and into the device. The user can spin their wheels freely until they are content with the cleanliness of their drive wheels. The user can then roll forwards off of the ramp. Finally, the bin can be cleaned to prepare for the next use. Our final design has 4 main systems, these being the 2-stage ramp, the self-contained frame, the brush and rollers that are held by the frame, and the ratchet gear locking mechanism. The 2-stage ramp allows the users to roll up the first incline with momentum in one push, then stop in the middle to regrip their wheels, and finally roll up the last smaller incline into the device. The low angle of each incline allows for easy backward ingress. The frame is also a closed system, so any debris deposited into the frame can be cleaned by removing the components and vacuuming or dumping out the dirt. The frame has small notches and pegs where the brush and rollers can be held when in use and removed for cleaning purposes. As the brush gets worn with use, the parts will be modular and can be replaced when needed. The last system is the ratchet gear and pawl, which allow for unidirectional spinning. The rollers spin as the user rolls onto the device and during the cleaning process. The rollers then lock as the user rolls forward and off of the device. As an overview of our device, cleaning takes under 5 minutes based on the user's preference. The design is compact enough to fit in the trunk of a car. Also, the design is intuitive and easy to use. Furthermore, the device is a closed system and can be cleaned within 5 minutes by removing the components and dumping out the debris. Since there is a wide market of wheelchair users that have issues cleaning their wheels, but there is no existing product on the market, the device has a high market value. Here is the device in action with the different systems highlighted. And here is a 3D rendered video of the entire system showing how the parts interact as a whole. In order for this device to be mass-produced and sold, we would want to develop the design more. The next steps include testing the final prototype under real-life conditions and quantifying the effectiveness of the device. Furthermore, we want to explore altering the current ratchet gear system to a locking mechanism that would allow for spinning in both directions while cleaning. Finally, we would want to create a telescoping spacer bar to connect the units. This would make sure that each user can adjust the distance between the units to fit their unique wheelchair dimensions and consistently keep those units as the correct spacing. We hope that this idea can be further developed after the semester is over so that the wheelchair users can have peace of mind that they are not tracking dirt around when they enter their homes. We want to give a special thank you to the professors and wheelchair users that have helped us during this project, and thank you for listening.